fix that before I actually share the screen with you. So my friends. Can you please try the warm-up I'm about to put on the board? Thank you so much. There's going to be one addition problem. There's going to be one subtraction problem for both of them. So I'm just going to say add. Let's make sure I'm on the screen. So add or subtract, depending on whether there's an addition sign or a subtraction sign. Write your answer in standard form. So we have that form just so all of our answers look the same. If not, everyone will put stuff in a different order and it would just be confusing. And you also want to name your answer. Okay, I don't even know what that just says, but you get the idea. Sorry, just always trying to make sure I'm actually on the screen for you guys. So let's do 2x squared plus 3x minus 1 plus x squared minus 6x minus 2. That's your addition. Once again, if it say add or subtract, just look at the symbol in between. That's an addition sign, so you're adding them. And then number 2. And there's a subtraction problem because there's a minus sign. So can you take the next, I don't know, 2 minutes and just see, can I remember what I was doing from yesterday? That's always key, right? We do something, we want to remember it. And if not, can you use your notes? And if you can't use your notes, can you ask a question? So that's the main thing. I did put your grades in for that test assessment, whatever you want to call it. The PowerSchool is like not working again, so I don't know if you can actually see it yet. I don't have a few issues. So at some point try to check it, but I think I put it in this one. Looks like I was actually measured it. Now I can actually see what that is, which is in their column. Once again, like I get it, if you don't know the names, I feel you. Just feel free to use your notes to look them up or just start to kind of try to remember them as you're going through.
So we all have a quiz. So remember, here are copies.
About 30 more seconds. All right, my friends. Let's see if we're okay with this. And if you're really not getting this, please ask a question. Because once again, If this is the first section and you're confused on this, that might make for a real long chapter. So always ask if you got it. So I say to myself, well, what am I doing? Well, adding. I always like adding, right? You just add together. So I'm combining my terms, so it's more just about organizing first. I remind myself to combine something, they need the same exponent. So if this has an x squared, I can only combine it with something that has an x squared. And I'm combining them using the numbers in front. We call those the coefficients. So if I have 2x squared and I'm adding, I can remind myself that's 1x squared. I just add 2 plus 1 to get 3. For addition or subtraction, you do not touch the exponent. It stays the same. So please do not write x to the 4th. No. Okay, exponent stays the same for addition and subtraction. So just be careful. If you changed it, please change it back. Now let's say, oh, okay, well I got 3x. I can add that with negative 6x. Just make sure you're looking not only at the coefficient, but at its sign as well. So if I have 3 plus negative 6, that would give me negative 3x. And last but not least, we call these the constants, just like the regular numbers. I have negative 1 plus negative 2. Oh, I didn't even plan that. Oh, my coefficients were 3. So you get 3x squared minus 3x minus 3. And then it asks you to name it. Once again, just as a heads up, standard form, this is in standard form. Because if I look at my exponents, they're kind of going down in order, leading to my constant. And the name of this would be a quadratic trinomial. So just use those charts and you should be okay. Does anyone have a question with number 1? Fabulous. So number 2, this I always kind of tend to do this step when I see subtraction. With subtraction, we tend to sometimes mess up signs, just like double negatives or if I'm not subtracting from anything. So usually what I do is I take that minus sign and I distribute it in, just like a negative 1, to get negative 2x squared. 2 negatives make plus 7x. And if I have a negative times 4, that would just be minus 4. Then from here, I'm just combining like terms, and I try to make the least amount of work for myself. So I like to make it so it's in standard form to start. So I just start where the highest exponent is, which is right here. And there's nothing to combine with that because there's no other x squared, so I'm just going to put that term first. So what happens sometimes if you don't distribute the negative, you'd be like, oh, you don't have anything over here, and I just have the 2x squared. But since it's nothing minus 2, it actually ends up being negative 2. That's why I like to distribute that. It kind of takes care of it for me. Then I got the 5x. I got the 7x. That gives me 12x. And I got negative 3 minus 4, and that will give me negative 7. So that would be my final answer, my polynomial. Ooh, magical. This is also a quadratic trinomial. I didn't even plan that. So quadratic means anything raised to the second power. We're going to do our whole next unit is called quadratic. And trinomial means there's 3 terms. So just as a quick review from yesterday, does anyone have any questions or anything you would like to go over before we move on to do some other stuff? Let me go over here so I can see you. So I can see my things. Sorry, I'm just signing on my other computer so I can see the chat without disturbing my phone. Okay, you guys are good. All right. So main thing, you're adding and subtracting. So that's not too crazy of a concept. The big thing is remember you do not change exponents because that's going to, when we multiply, that changes a little bit. Remember you have to write things in order from highest to lowest, pay attention to signs, and then be able to use that chart to name. So the next part's kind of quick, so we'll just do a few, you'll try a few, and then that'll be kind of it for today. We're going to quickly just go over distributing, something we're familiar with because we've distributed basically all the time since the beginning of the year. And then we'll talk quickly about GCF, which is greatest common factor. And we'll try a few problems and that'll be today. But this stuff, as much as it, like when you do it by itself, it's like, oh yeah, that makes sense. It's when you start to kind of mix things together, maybe do a few things in one problem, that can get a little confusing, so make sure you're good with the basics. If you're good with the basics, you're good. All right, let me erase here. And I'm gonna say the next directions will say multiply. And when we're multiplying with polynomials, that'd be a little funky, right? But let's say we'll keep it kind of basic and we'll say 2 times. So that's kind of the most basic, now we'll work our way up. So this setup looks familiar to us. When we see a set of parentheses with something outside of it, we're going to take whatever's there and distribute it. We've seen that as we've been solving equations throughout the year anyways. Now it's just our polynomial might be a little bit longer, but it's the same concept. You take this outside term, and since we have a trinomial here, you're going to distribute it to all 3 terms. And we're just multiplying. Okay, I can do that. 2 times 3x squared will just give me 6x squared. 2 times 5x will give me 10x. And 2 times -1 will give me -2. That would be my answer. So the concept we're familiar with. What happens sometimes though is maybe we throw in some different variables and we want to just be comfortable with that. So let's do 5x squared times 3x to the third plus 2x squared minus x plus 11. So I said to myself, okay, well, it looks like the same setup, so I'm feeling pretty comfortable. We do have a polynomial with 4 terms, so whatever's out here, you do have to distribute 4 times. Now, it's almost like we do things in a certain order in math. It's magical how that happens. Because we are going to be multiplying with exponents. So can someone remind me, for this first term, I know that 5 times 3 is 15. But what do I do with these little exponents here? I add them. Remember, that was one of our properties. So that's why we kind of do the properties first, because they kind of just are going to keep popping up. So our goal is we multiply the coefficients, we add the exponents. Please do not multiply the exponents. No. Add the exponents. And we basically just do that 3 more times. So for the next one, we multiply the coefficients, I get 10. We add the exponents as x to the 4th. And you just kind of keep going. Multiply the coefficients. If you want to throw a 1 there, that would just be, oops, excuse me, that's -5. Add the exponents. A few of you did make this mistake. You forgot that here, this does have an exponent of 1, so just be careful there. So that would give me 5x to the 3rd. And last but not least, when you multiply the coefficients and you get 55, there's no exponent to add to that, so it just stays as x squared. That's what your final would look like. So it's just bringing in, it's kind of just like a bunch of stuff that we know. We're just kind of putting it together though. So we know how to distribute, take that outside term, multiply it in. We know how to do stuff with exponents. It's just reminding ourselves of it all. So when you're multiplying, multiply coefficients, numbers in front, add exponents, and you kind of just keep going for that. And then let's just get used to our names. If we were going to name it, this would be a quintic polynomial with 4 terms. That was a quadratic trinomial. Yeah. We like quadratic trinomials. We see them a lot. So going off of that idea, can you guys try this one? Let's do 6. Let's use a different variable. We'll do a to the 4th times 4a squared plus 3a minus 1. So if I said, hey, can you distribute that, knowing what we know about distributing and about exponents, see how you feel. If there's no questions, I'm making the next one a little bit harder, so ask a question if you got it. Ooh.
Mr. Sherman, so it's not about this problem, but say like, instead of it being 3A, it was like 3B, it's a different variable, would you
I'm
multiply?
gonna do that next, so
Okay.
there's a step ahead of me. That was the next thing I was gonna do, we're gonna put some different variables and see like, what the heck do we do? We have A's and B's and C's and what can we combine? So we'll do that next, but thank you for asking. We'll give you about 30 more seconds.
I have a quick question.
Oh yeah, go for it.
When you do these, do you have to name them?
Not unless I didn't specifically tell you to, so no. So unless, always put it in the directions if I expect you to, so. I did not tell you to, so no, you do not have to. All right, let's go over this one. Take my outside term, we're gonna distribute it in. Cha-cha-cha. And let's see what we get. Multiply the coefficients, so that gives me 24. Add the exponents would be a to the 6th. Okay. Multiply the coefficients is 18. And then that's, remember there's a 1 here, don't forget about that. That's a to the 5th. And then last but not least, -6, 6 times -1 is -6. And since there's nothing to combine with a to the 4th, it just stays as a to the 4th. So can you please do a quick check of that one and see how you're feeling? Any questions or issues? All right, let's look at one with a few variables, because once again, the concept isn't bad. I can multiply all day long. But sometimes, when you see a bunch of stuff, that's when we get confused, so let's throw this one, give me a second to make it up. Let's do 2 c to the 4th d e to the 3rd times 6 c to the 3rd d squared e squared plus. Sorry, it's gonna take me a second to make this, and I'll give you a second before I start it. E minus 4c. And we'll just make it. So once again, the same concept, the same idea, it's just like we have a bunch more stuff happening. So when that happens, you just have to do one thing at a time and stay organized. That's about it. So I look at this and I say, we got numbers, we got different variables, we got exponents. So we're gonna do one thing at a time. I know I'm gonna distribute, it is a trinomial, so I'm gonna have 3 terms, right? Because polynomials are separated with addition and subtraction. So this concept is always kind of weird. This is one term. So I know it's weird because there's a few different bases, but it's one term because terms are separated with addition or subtraction. So this is another term and then a third. So we have 3 terms. So I'm going to take this and multiply it by the first term. You just have to kind of stay organized and do it in order. 2 times 6 is 12. And then just for each individual base, you add the exponents. C to the 4th times C to the 3rd is C to the 7th. D, I'm going to throw 1 there just to remind myself. D to the 1st times D squared is D to the 3rd. And E to the 3rd times E squared is E to the 5th. Okay, so I just do one thing at a time. If you start looking at the next part, then you really get confused. So that outside term times the first term, I just went through basically each base and said, what could I combine, and went from there. So I say, ooh, how exciting, we have 2 more to go. So let's go to the second term. 2 times 5 is 10, so I'm gonna put plus 10, because remember the plus separates them. And then C to the 4th, C squared, I add the exponents is C to the 6th. D to the 1st, that's also D to the 1st, would be D squared. And E to the 3rd, E to the 1st, I add would be E to the 4th. Okay, wasn't bad when you just kind of take it one thing at a time. And last but not least, let's do tosses. 2 times -4, or just remember that minus is 8. C to the 4th and C to the 1st is C to the 5th. And then remember, if there's nothing to combine with those other ones, they're just going to stay. So if you have D to the 1st and you have nothing to combine, it's just D to the 1st. And then E to the 3rd just stays as E to the 3rd. And then, my friends, it's not the nicest looking answer, but that's your answer. So don't get freaked out when you see like a few things going on. You just do your best to use the concept that you know, which is distributing. When you distribute, you multiply. So what do? You multiply the coefficients, you add the exponents of the bases that are the same. Remember, you can't combine a D with an E and stuff like that. Are there any questions? I was going to give you a second. Oh, wow, I'm kind of hot.
We should go out to.
We'll see. I just like get annoyed. If you go out not on mass break, you have to call the office and then tell them you're going out. And it's like a big process. And no one ever answers the phone.
Do it so we can leave.
No. So rude. Don't keep me messing with them. Anyways, I was just thinking, like, imagine when like school gets hot. Like, what if it's gonna be? It's gonna be like almost in the 70s on Thursday.
Yep.
Because we can't use fans.
Yeah.
Like, how sad is that gonna be? Like, I'm just thinking about it being hot with a mask on with no fan. I already can't breathe. Just be prepared. Bring cold water. It'll be okay. Anyways, that's the idea for distributing. So does anyone have a question if we just have that one term on the outside, how we distribute or simplify or any of anything? Okay, that's exciting. Once again, it's like stuff you kind of know, but I'd rather always go over it than just be like, hey, you know this. So the last thing that we can quickly do today is called GCF, which represents greatest common factor. But we do say GCF quite a bit. Even the book calls it GCF because, like, who really wants to write greatest common factor 1,000 times? But let's just kind of go over the concept of greatest common factor. So it's kind of all in the name. Once again, we call it GCF quite a bit. I just get lazy. I don't want to say it a million times. But think about it. Greatest is the largest. Common is what they have in common. And factor, we are going to use the word factor quite a bit. And you guys know it. Like if I say what are the factors of something, you just divide it up. Factoring is dividing. So that's what it means. We're finding the biggest common number that we can divide out.
Yep.
So let's see what an actual problem looks like. Let me give you some nice numbers here. Let's do 8x squared plus 16x plus 4. Hey everyone, what is the greatest common factor? So what's the greatest number that those are all divisible by? What would it be? 4. So you could be like, oh, well, they have a 2 in common. And you're right, they are all divisible by 2, but it has to be the highest number that they're divisible by. So that's the point of saying the greatest part. So we would just say to ourselves, oh, well, what are these all divisible by? They're all divisible by 4. That's the highest number. So you write that GCF on the outside. And then what you do is you go back and divide each of these by 4. And that goes in parentheses. It kind of actually just looks like we're backwards distributing, right? We're taking what they have in common, but we're taking it out. Whereas when we distribute, we multiply it in. So when I do that, I would be left with 2x squared plus 4x plus, please don't be like, oh, that cancels. You have to put something there, so you put a 1, because 4 divided by 4 is 1. But if you have a trinomial, you should have a trinomial inside. But that's what a GCF problem looks like. What do they have in common? We're dividing it out. So now that's on the outside. And then in parentheses, you would have whatever is left once it is divided out. So you guys had said, like, you had heard of GCF before. Let's do it with variables now. Ooh, how exciting. No, I was gonna be a little fancy here. Give me 1 second. Let's do 7x to the 5th So if I said, hey, what's the GCF of this? You'd probably be like 7, 5, 11. They have nothing in common besides 1. I mean, I guess everything's divisible by 1, right? Those are all prime numbers, that's fine. But they do have something in common. Does anyone know, besides just saying 1, what do those all have in common?
Variable?
The variable, so they have an x in common, but they all have exponents. So like, what do they have in common? Is it just x? Is it x squared? Is it x cubed? Is it x to the 5th? Does anyone know or can anyone guess? So when you see they have a variable in common, because they all have an x, you're gonna say, ooh, well, they all have an x in common. But since these all have exponents, you have to kind of take that into consideration as well. When they all have exponents, you take the one with the smallest exponent. So my GCF, if you want to throw 1 in front of here, is 1x squared. So the reason being, to kind of think about it, this has 5 x's, this has 3 x's, and this has 2 x's, so they all have at least 2 x's. These ones obviously have a little bit more, but when you see variables, I'm just going to make a note to myself, if GCF is a variable, take the smallest exponent out, because we're dividing it out. Not the best English I've ever written, but we'll go with it. So then let's say, well, okay, I'm gonna divide it out, but then like, what will my answer look like? So reminder, once you decide what they have in common, we're gonna take that out. You go back and divide each of these by 1x squared, or just by x squared. And then that goes back to our properties of exponents, my friends. When you divide, what do you do with exponents?
Subtract.
You subtract them. So you divide the numbers in front, that just gives me 7, but you subtract the exponents, x to the 3rd, plus 5 divided by 1 is 5, subtract the exponents is x to the 1st, minus 11 divided by 1 is 11, x squared over x squared, 2 minus 2 is 0, anything to the 0 power is 1, I can just cancel those. And that, my friends, is what my answer looks like. So we'll do a few more with the variables just to get used to it. But greatest common factor, what do they have in common? What's the highest thing they have in common? Divide it out. Whatever you got left is your answer. Let's try another one that has some variables involved. Let's do 18 e to the 7th plus 12 e to the 5th minus 24 e to the 4th. And let's just throw in one more, let's make life exciting today. We'll do 36 e to the 3rd. All right, so my main question as I look at these is, what do these all have in common? I usually kind of do it in 2 steps or a few steps. I look at my coefficients first, and I kind of just focus on one thing. When I try to look at too many things, I get all confused. So let's just focus on the coefficients. 18, 12, 24, 36. What is the highest number that those are all divisible by? You just yell it out. Just yell it out. 6, right? So technically they're all divisible by 2 and 3, but those are not the greatest common factor. The greatest is 6. So I kind of do that first, and I say, all right, well, now we see variables. E to the 7th, e to the 5th, e to the 4th, e to the 3rd. What should I put in my GCF? E to the 3rd. Ooh, yeah. So once you kind of know it, it's quick. It's like, oh, you just take the one with the lowest exponent. So it's not necessarily the hardest step. It's just something you have to kind of either write down or remember and get used to. And then you go back and you divide each of these by 6 e to the 3rd. I like to kind of do it individual just so I see it. So the first one, I'd be left with 3 e, remember, subtract those exponents to the 4th, plus, I'll divide that by 6e to the 3rd. I will get 2e squared I divide this by 6e to the third, I'd get minus 4e. And last but not least, I would get plus 6, and the e to the thirds would cancel. That was kind of messy, but you got the idea. And that's just that. So we're just gonna do one more problem. Excuse me. So let's do our last one. Or let me erase what you guys are, if you're writing that down. All right, well, I mean, I can't make it too easy on you. So let me write that, let me just think for a second. Okay, here we go. Let's do 15, a to the fourth, b to the third, c. Ooh, let's just get really crazy. Plus, sorry, I'm gonna move in a second. I know I'm blatantly in the way, but it's just like, this is how I think, this is how my brain works. All right, now moving, sorry. So we got some coefficient, we got some numbers, but now we have, instead of just having one variable, we have 3. Gotta organize that brain. So let's go through and just kind of do the process together. So once again, one thing at a time. Just pick one thing and find the GCF of that. I'm gonna do the numbers first. So I think 15, 9, and 12, those are all just 3, right? Yeah, so 3. So one thing at a time. Now I'm gonna do the A's. So I just pick one variable at a time. Especially when you see a lot, you can tend to get overwhelmed. One thing. A to the fourth, a to the third, a squared. I'm gonna take my smallest exponent, which is a squared. Does that make sense? B's. B to the third, b squared, b to the, that's to the first, right? So the smallest exponent is just b to the first. I like to throw the 1 there just to remind myself it's there, so I don't forget. C, no C. Should I put a C in the GCF? No, because right, in order to go in the GCF, they all have to have it in common. So if 2 of them have it in common, we're happy for them, okay? But in order for you to take it out, it has to be in all of them. So if it's not included in all of them, it's not a part of your GCF. So just as a heads up. So that's my GCF. That's what all of the terms have in common, the greatest thing. So I'm gonna go back and divide each of them by that. 3a squared b to the first. I like to kind of rewrite it. You can see if you were just kind of like throwing this one together, you can get confused a little bit easily. So rewrite everything out. Divide your numbers in front, that gives me 5. Subtract your exponents. So that would be a squared, that would be b squared, and c I have nothing to subtract from, so it just stays as c. Plus 9 over 3 is 3. And then that would give me a to the first, b to the first. And once again, c is kind of just chilling, it stays, or you can write it as c to the first. You don't need to put the 1s, but you just out of habit sometimes throw them there when I don't really need them. And last but not least, minus 12 over 3 is 4. A squared over a squared would be a to the 0, which is just going to be 1, so we can cancel it. And then same thing here, the b's cancel, and that would just be your final term. And that is what that beauty will look like. My arm hurts too much. We're trying to make sense. All right, so those are the main concepts of today. So we're going to remind ourselves. Tomorrow we'll kind of like play a game. I'll try to look something up that's semi-decent and fun. We will have a little bit more distributing on Thursday. Once again, you know the concept, so it's just kind of bringing in some different setups. And then Friday will be a practice day of everything. Add, subtract, distribute, GCF. We will have a little quiz next week. It will be 2